Looking at a severe weather day in the southern plains, and it appears active in the panhandles with a major weather system coming out of the Rockies. As you saw in the opening clips, we've got tropical moisture flowing northward across Texas, and there's dense layers of stratocumulus indicating very rich moisture up at about 2,000 to 3,000 feet. There's what we have on the national map, a very complex picture. Let's break it down into easy to digest portions. We've got the tropical moisture down there in Texas. You can see that's made up of 70s temperatures with 60s dew points and very cloudy conditions. North of that, cooler air in the Midwest and in the central Mississippi River Valley. Temperatures ranging from the 30s up to the 50s. Further north, we've got a fresh infusion of polar air coming out of the northern plains and Canadian prairies. And then we've also got the Pacific air moving eastward out of the Four Corners area. And then in between, it looks like we might have a dry line. Not too sure about that. Once you go back behind that dry line, it does become very hard to distinguish cold air from post-dry line air. However, we do see kind of like a very narrow corridor of warm temperatures all the way out to Midland. And then as you go west of Hobbs, west of Carlsbad, it looks like we have some substantial cooling. You can see that 49-degree temperature there at Albuquerque, 42 at Klein's Corner, 65 at El Paso. If this was dry line air, we would expect this to be probably 20 degrees warmer. So this is all part of the polar air mass coming out from the Pacific. So my tentative location of the polar front is right there. And the more I look at this situation, the more I think this front here is linked up to that warm front, and this front here is linked up to the stuff coming out of the Dakotas. But since we're starting to focus on the mesoscale, those are kind of semantical details. Let's look at the upper air pattern. This is up in the upper troposphere. Yeah, we've got progression of all these waves that we talked about on yesterday's supporter video, and we discussed the Hove-Molar diagram and all that. This trough emerging out of the Four Corners area, that's going to destabilize things across the panhandles this afternoon. And we also see the presence of a 110-knot jet running from about El Paso up to Amarillo and over to Topeka. Here's the 18Z high-resolution rapid refresh. I usually like to start with dew point and wind field. That's what we're looking at here. And we see the turquoise indicating 60s dew points and the purple shades indicating 70s dew points. And we can see that the moisture axis runs from about Waco up to Wichita Falls and Altus. Now I am kind of starting here with the models to kind of speed things up. I think the high-resolution rapid refresh at this point is going to be doing a pretty good job. We saw on yesterday's supporter stream that the high-resolution rapid refresh did not actually work very well for 24 to 36 hours out. The NAM did a better job with that. I mean, if we take a look at the forecast soundings for this afternoon, we see a cap there and some steep lapse rates. The NAM was forecasting that, but the high-resolution rapid refresh was not picking out those details yet. And some of that could be boundary problems due to the limited domain of the high-resolution rapid refresh model. This model is also showing some details that indicate where the cold front might be. Right in here, I think we're actually picking up the cold front there, and right there would be the location of the dry line. We can say that that's from Childress down to around San Angelo. And as that cold front emerges, you can kind of track that as it moves out onto the plains there. And as we go far back into that cold air, we're not going to find anything like the classic frontal inversion. But you can see we've got cool temperatures down here and very cold temperatures in the mid-levels. So that's going to be back behind the front. And you notice that the origin of the air appears to be coming from Utah in northern Arizona, not from Mexico and Tucson and El Paso. Now, typically in these situations where we have strong boundaries, strong upper dynamics, we have to be alert for early convection. And sure enough, that does seem to be the case. We can see not only the boundaries, but the showers and weak thunderstorms firing along those. Now, these have not yet moved into the deeper moisture. We know from the maps that we've seen that that's lurking right around there. That has yet to flow up into that area of strong lift. So we've still got a few hours before we start seeing deep convection with severe weather potential. And we can see indeed that this is going to be the front. I do have some question of whether maybe it's past El Paso already, but this is certainly a boundary. Well, the dry line is not really showing up yet. Starting to see a little bit of maybe high-based convection around Knox City, Aspermont. Another thing that we see here is on the western edge of the moisture, there is some erosion going on. The high-resolution rapid refresh was indicating that the moisture axis was right around there. So it appears the strong westerly flow and the strong heating in this region here are causing that moisture to erode and get carried out into the elevated mix layer. Going north into Oklahoma along that warm front, let's go up to El Reno. A frontal inversion, some elevated moisture, and a cap above that. Now we're expecting this to change enormously. Let's see what happens here after about 4 hours. We'll go to the same place. And you can see some dramatic steepening of the lapse rates, 850 to 700. So this is indicative of strong upper level energy. You can see that strong lift there in the omega plot. Probably a strong shortwave emerging out onto the plains. Still seeing that frontal inversion right there, but we know that that's going to be weaker out to the west. Now with that steep lapse rate, we have pretty good cape here, and we've got the hook shape in the photographs 0 through 1 kilometer shear, pretty substantial. The SRH there, 350. That's in line with what we saw yesterday on the NAM for today. And the automated algorithm indicating some tornado potential. Now the problem is with these strong boundaries, with early convection, there's going to be substantial cell competition today. So any tornado potential could be wiped out by clusters of cells and lines entering western Oklahoma. So tornadoes to a certain extent will come down to mesoscale accidents. We can reveal the most likely places for those accidents by looking at the SRH from 0 through 1 kilometer. There's how it looks right now. This is north of the warm front. It's too stable. The dynamics have not reached this area, so it's not something that can be realized. But as we go through the afternoon, we want to take a look up at this area right there. That's where things are going to come together, and I think maybe we've seen a slight southward drift, maybe to the I-40 corridor. And then it looks like it lifts a little bit north around 6 p.m. So probably one place I might want to be is somewhere around I-40, around Weatherford maybe. if I was out chasing. This would be a very difficult chase because everything's moving fast and you've got multiple cells. And you can see how fast everything shifts eastward through the evening, indicating substantial upper air support. Here's the upper air support looking at the GFS. There is noise in this data due to terrain interactions and instability in the mid-levels, but I do think there is a shortwave through somewhere in that area, and there's a lead shortwave. Let's see what happens going into this evening. Yeah, one very strong slug of vorticity right there, indicating very strong lift working on central Kansas all the way down to central Oklahoma. And then you see by tomorrow morning, all that shifts up into Illinois. So that's some potent upper level lift. That's that PVA we were talking about that indicates upper level divergence and low level convergence. Here's what we have for dynamics on the NAM for this evening. Strong advection lobe right there, indicating a strong shortwave. Moving in Oklahoma, if we back that up 3 hours, we can see that's emerging from the Texas Panhandle, and we back that up further to now. Yeah, all that lift is, I don't know, it's probably going to be somewhere in there, actually, I think, maybe around Tucumcari. And that's tied into the extensive activity we see right here at this hour. So all that lift, it's going to continue heading eastward this afternoon, and we should see some pretty good storms out there in western Oklahoma, possibly up to Kansas this evening. So we haven't even looked at the breakout of precip. Let's check that out. So this is 19Z. We can use that as an initialization. Looks like some cells around Dalhart out towards Naravisa, north of Tucumcari. Yeah, it's in the ballpark. It's good. I'm not sure it's really picking that up yet. That stuff there near Borger and Pampa. And the progression on the high-resolution rapid refresh. Yeah, those are the cells we were interested in right there. These here may be a little bit too cold, maybe a little high-based, but... And also the wind flow. Let me just bring you a skew-t here, just out ahead of those. You can see that the helicity is not that great there due to the extensive westerly flow. So these are not going to have much severe weather potential in the Panhandle. It's these out here. Let's look at a skew-t just north of I-40. Little uncapped up there, some good shear. And as we go further south, around Mangum, Hobart, some very steep lapse rates and some good shear. But these are going to be moving very fast. You can see the right motion vectors out of 240 at 40 knots. So that's going to be a really tough chase. Best thing to do if you're out there is basically plant yourself in one spot and hope for the best. And then getting into this evening, yeah, there's a couple sails right there. There's probably some question of how far south of I-40 they're going to go. But some decent ingredients will be there. Good SRH, good lapse rates. Moisture is a little bit scarce. I think that's going to be a problem on those western cells. You can see as you go further out east, the moisture does look better. So you wouldn't want to get too far west on these things. Everything is moving rapidly to the east. So if you're out chasing, you would also have to keep on top of that and keep east with the better moisture. And that's, to a certain extent, why it's important to go visual and recognize when the environment is looking less conducive. High bases, lower relative humidity, more of a westerly component in the winds, those would be negative factors. We're actually getting some rain right here. We're out here in the tropical moisture supply, just north of the warm front, and definitely some unsettled conditions here. So here's the ARW model. This is always a good one. This is a run from this morning, and they've got stuff on the tail end, maybe just north of I-40. tracking towards Enid. Clusters of cells, probably linear to a certain extent. So, yeah, this would be a tail end chase, I think. The 0 through 1 kilometer SRH. Here's how that's going to shape up. That's 22Z, 23Z. Okay, this is bringing it a little bit further north. So this favors, I guess, Watonga, Dover, up in that area. So that's probably going to be the play for today. Shifting, of course, east. After 0Z, you're not going to have much light at all, but, you know, you might be out photographing lightning or something, and that would put you probably in the Stillwater area. Oh, I should probably look at the SPC Day 1 outlook. There it is, slight risk from roughly Woodward down to Oklahoma City, up to Tulsa, and up towards Medicine Lodge. Yeah, and we've got our first mesoscale discussion there. That came out about an hour ago. They're looking for tornado risk out ahead of that cluster that we saw on the ARW. All right, so we've used up 16 minutes. It's time to wrap this up and get it out so you all can use it. So really not much question about severe weather. There's some slight tornado prospects in northwest Oklahoma, maybe some question how far north or south. Could be anywhere from near I-40 up to the Enid area, maybe up northwest of Watonga, and possibly over to I-35 later around dusk. So we'll see how that goes. And we'll return to the dynamics lessons tomorrow. Hope you have a good one. Take care. Bye-bye.